Biotin Synthase, BioB, EC 2.8.1.6, is an enzyme that catalyzes the conversion of dethiobiotin, DTB, to biotin. This is the final step in the biotin biosynthetic pathway. Biotin, also known as vitamin B7, is a cofactor used in carboxylation, decarboxylation, and transcarboxylation reactions in many organisms including humans. Biotin synthase is an S-Adenosylmethionine, SAM, dependent enzyme that employs a radical mechanism to thiolate dethiobiotin, thus converting it to biotin. This radical SAM enzyme belongs to the family of transferases, specifically the sulfurtransferases, which transfers sulfur-containing groups. The systematic name of this enzyme class is dethiobiotin sulfur-transferase. This enzyme participates in biotin metabolism. It employs one cofactor, iron-sulfur. In 2004, the crystal structure of biotin synthase in complex with SAM and dethiobiotin was determined to 3.4 angstrom resolution. The PDB accession code for the structure is 1R30. The protein is a homomer, meaning it is composed of two identical amino acid chains that fold together to form biotin synthase. Each monomer in the structure shown in figure contains a TIM barrel within 4Fe4S2+ cluster, SAM, and in 2Fe2S2+ cluster. The 4Fe4S2+ cluster is used as a catalytic cofactor, directly coordinating to SAM. Orbital overlap between SAM and a unique Fe atom on the 4Fe4S2+ cluster has been observed. The predicted role of the 4Fe4S2+ cofactor is to transfer an electron onto SAM through an inner sphere mechanism, forcing it into an unstable high-energy state that ultimately leads to the formation of the 5-deoxyadenosyl radical. The 2Fe2S2+ cluster is thought to provide a source of sulfur from which to thiolate DTB. Isotopic labeling and spectroscopic studies show destruction of the 2Fe2S2+ cluster accompanies BioB turnover, indicating that it is likely sulfur from 2Fe2S2+ that is being incorporated into DTB to form biotin. The reaction catalyzed by biotin synthase can be summarized as follows: dethiobiotin plus sulfur plus 2S-Adenosylmethionine \displaystyle\right-tharpoins. Biotin plus 2L-methionine plus 2,5-deoxyadenosine. The proposed mechanism for biotin synthase begins with an inner sphere electron transfer from the sulfur on SAM, reducing the 4Fe4S2+ cluster. This results in a spontaneous CS bond cleavage, generating a 5-deoxyadenosyl radical, 5. This carbon radical abstracts a hydrogen from dethiobiotin, forming a dethiobiotinyl C9 carbon radical, which is immediately quenched by bonding to a sulfur atom on the 2Fe2S2+. This reduces one of the iron atoms from FeII to FeII. At this point, the 5-deoxyadenosyl and methionine formed earlier are exchanged for a second equivalent of SAM. Reductive cleavage generates another 5-deoxyadenosyl radical, which abstracts a hydrogen from C6 of dethiobiotin. This radical attacks the sulfur attached to C9 and forms the thioethane ring of biotin, leaving behind an unstable diferrous cluster that likely dissociates. The use of an inorganic sulfur source is quite unusual for biosynthetic reactions involving sulfur. However, dethiobiotin contains nonpolar, unactivated carbon atoms at the locations of desired CS bond formation. The formation of the 5-de radical allows for hydrogen abstraction of the unactivated carbons on DTB, leaving behind activated carbon radicals ready to be functionalized. By nature, radical chemistry allows for chain reactions because radicals are easily quenched through CH bond formation, resulting in another radical on the atom the hydrogen came from. We can consider the possibility of a free sulfide, alkane thiol, or alkane persulfide being used as the sulfur donor for DTB. At physiological pH, these would all be protonated, and the carbon radical would likely be quenched by hydrogen atom transfer rather than by CS bond formation. Biotin synthase is not found in humans. Since biotin is an important cofactor for many enzymes, humans must consume biotin through their diet from microbial and plant sources. However, the human gut microbiome has been shown to contain Escherichia coli that do contain biotin synthase, providing another source of biotin for catalytic use. The amount of E. coli that produce biotin is significantly higher in adults than in babies, indicating that the gut microbiome and developmental stage should be taken into account when assessing a person's nutritional needs.